Hello and welcome, friends. As far as leveling is concerned, in two lectures, you are already acquainted with vertical distance measurement and even simple and differential leveling in land surveying. In this particular presentation, I am going to discuss about profile leveling, cross sectioning, and reciprocal leveling. As you learn the content, you will be able to carry out the profile leveling work, as well as you will be able to plot the longitudinal and cross sections. You will also be able to carry out reciprocal leveling and determine the correct difference in elevation even if line of sights are not balanced. So firstly, let's try to understand what is the profile leveling. For certain construction features which are linear in nature, for example, it could be road, it could be railway, it could be canal, it could be pipeline, any kind of pipeline and similar structure, we deal with its line of alignment. Normally, we follow the center line of alignment of such features. So, we wish to know exactly what kind of terrain is lying all along that particular alignment, so that we'll be able to amend the existing profile and accordingly we'll be able to construct the features the way we want. So, this profile leveling is basic step as far as surveying work is concerned, as well as even the construction activity of such features is concerned. On the right side, here what you see is certain proposed alignment A, B, C, D, E. So here what you see is plan. So the way we considered earlier, now we'll be setting the equipment at various locations, thereby we'll be able to establish the control over these particular stretch A to E with minimum instrument setups. So here we expect to take the readings at certain regular interval. In addition, as the stretch could be having considerable lengths, we may be coming across some different features, maybe natural, maybe man-made. So we wish to understand and we wish to locate their location exactly. Hence, the readings are also taken at such critical points. In addition, the way you see, say, that particular line AB is changing its direction at station B, at station C, at station D. As such, here we have to take the reading at the station, though it is not placed at the regular interval, in order to record the change in direction and its elevational aspects. So here this particular line indicates the equipment position and the various stations that have been located in order to cover this particular stretch. As we take the reading along the center line of the proposed alignment, the way we discussed previously, by making use of rise and fall method or collimation plane method, we will be able to work out reduced levels. Hence, we have the center line showing that particular regular intervals here, say 0th station, first station, second station. The interval could be anything which is conveniently chosen. Say for example, it could be 5 meter, it could be 10 meter, it could be 25 meter. It depends on the nature of terrain and kind of result you wish to obtain. So, you can plot this particular line indicating the position of the stations. With respect to that, we can plot the various elevations that are worked out as ordinate. And accordingly, we will be able to determine the exact profile of the land that is lying in between the stations under consideration. In order to understand this in better manner, let's refer to this particular sketch. So, the lowest line is telling us about the chainage. The way you see, here the stations are located at, say, 25 meter interval, 725, 750, 775, and accordingly. We have determined the reduced level, and that reduced level is plotted at this particular line. Now, we can note down the lowest possible reduced level, and with reference to that, we can choose some convenient data. So, this particular data value will help us to plot the location of that particular stations as ordinate. So, say this is certain reference line indicating 98 meters. Now, the station has reduced level of 99.585. So, with respect to this particular, say, 98 meters, we can plot vertical ordinate of 1.585 meters so that we can look at the position of that particular station. Similarly, here the way you see, this is some 99.515. Again, we can produce 1.515 ordinate in order to plot this particular station. So accordingly, here just we can move further. Accordingly, we'll be getting all that particular ordinates. As we plot the heads of all that particular ordinates, we'll be able to get the actual profile that is lying in between station, starting station and ending station. Here, we must keep in our mind again the way we discussed previously, that actual center line may not be just in single direction, but there could be many changes in its direction. So accordingly, here wherever that change is, that change in direction can also be presented by showing different RL that is not exactly at that particular regular interval chosen, defined, but it is simply the RL of that particular station C. Here, you can make this kind of notes in your field book in order to signify the location of that particular stations. One more thing is, as we wish to have these particular vertical profile seen experienced in enhanced manner, we usually follow vertical scale 10 times exaggerated as that of horizontal scale. So the way you see here, the horizontal scale is 1 is to 100, but the vertical scale chosen is 1 is to 10. Furthermore, as we have this particular actual profile, now we can decide conveniently how we wish to alter this actual profile. So for that, we can define some line which is called as formation line. So here the blue line that you see is nothing but formation line. It can also be treated to be grade line showing the desired profile. So here for my convenience I have considered these as horizontal line. It could be inclined in any manner the way we wish to construct the actual structure on the top of this particular grade line or formation line. So obviously there is a vertical ordinate as we consider the placement of this particular blue line and as we consider this particular red line, the vertical ordinate tells us the amount of fill required. So here the way you see, this is the placement of the station, say at 99 meters. But for example, I wish to have this particular point set at some 100 meters. That means I have to raise this ground by filling the existing ground level by 1 meter. At this particular location, say, the formation and the actual existing is almost same. Hence, there is no requirement of further filling. With respect to this particular blue line, now this particular ground is actually placed above. But we wish to attain this particular level. That means here we have to cut this particular portion. Similarly, I hope now this triangular portion needs to be cut, whereas this W-like portion needs to be filled. Here again, these particular protrudings need to be chopped down in order to have this particular formation line. I hope the concept of required cuts and fills is clear to you with this particular sketch. When we deal with various project surveys, we will discuss more about this particular concept. Now, just we considered about that particular grade line. We wish to place it at requisite level. So, here what you see is this particular undulated line is presenting the actual profile. So here whatever that particular say section that you have drawn here, it is called as longitudinal section. It is also called as L section. So here it is indicating us the actual profile. The way we can consider placing the grade line or formation line. Say we have set the equipment. As such, we have defined the line of sight at 100 meters. That is, HI of the equipment is 100 meters. For a given situation, the existing ground level is 98 meters. Whereas at that particular station, we wish to have the level of the formation as 98.5 meters. That means as we deduct this particular 98.5 meters from the 100, it will give us the exact location of formation, the way we wish to attain this particular desired profile. Hence, we can derive certain peg here, we can drive certain peg here, so that that particular top of peg will be giving us that reduced level of 98.5 meters. So such readings can be worked out by making use of this particular simple relationship, that is grade point elevation can be given as HI minus grade stop reading. So here this HI is known, this grade point elevation is known, hence you can work out that particular grade stop readings, and that grade stop readings will help us to attain the required desired land profile. So for this, the peg that we use is called as grade stack. In order to attain the requisite level, it could be driven in the ground, or it could also be raised up, so that its top will be giving us the requisite calculated level. Similar concept is of cross sectioning. What the thing is that we work for limited width, making inclination of say 90 degrees, so that we'll be able to have even the cross profile known. Earlier, we were dealing with simply center line AB, BC, CD of proposed alignment. Now say, if we wish to construct the road, naturally it will be having some width. So, as we want to know how that particular formation can be done, so that that particular earthwork can be placed on the top of the existing actual terrain. So the way you see here, this center line is dealing with the alignment of the proposed structure. Now on L5, that is the station placed at 5 meter on the left side of center line, we have the reduced level. At 10 meters we have the reduced level. At 15 meters we have the reduced level. Similarly, on the right side also we have the reduced levels of all the stations placed at 5, 10, 15 meters. So the way we plotted the L section earlier, with the similar concept, we can also draw this particular cross section. As we connect the top of that particular ordinates, it will be giving us the actual profile that is existing at that particular cross section. One more thing is, as we have plotted the actual desired location of the point in form of formation line at that particular center, we have defined the requisite formation level. So with respect to that, here whatever that particular width of the structure that is proposed can be plotted on the left side as well as right side. Certain desired slopes to maintain the stability can also be plotted, and hence we will be able to proceed with further formalities required to design, estimate, execute, check that particular proposed structure. Just to understand one more concept, here at a glance we will be able to see the topography if we are showing some contours for that particular stretch on which we are working. So here these lines that we have shown here are showing the points of equal elevation. With respect to the value of that particular contour, we can understand how the actual terrain is. More about these as we proceed further. We have to be very particular as we take the reading. especially while placing the change point. We have to place the equipment in between the just previous station and the station to which we wish to ship the equipment. As such, we want to have the length of back side and foresight balanced, which is nothing but keeping the length of the back side and foresight equal. We need not measure that particular distance actually. In fact, in precise leveling, we do so by taking reference to study more about this as we proceed further. But here, we will try to understand exactly what do we achieve by equalizing backside and foresight. Say, we are dealing with two stations A and B. Now, according to the earlier concepts, we wish to measure along the level line, but practically the line of sight that we define is horizontal, as it is the line joining center of eyepiece and object glass and its continuation. It has to be a horizontal line. Hence, we are involving some error related with this curvature, as well as that particular curved line is not remaining or flowing as it is because of the change in density in vertical plane of the atmosphere in which we are working. The ray, the line of sight is also refracted, bent with respect to its horizontality. As such, the error is also involved because of refraction. Also, the line of sight that we have defined could be faulty. It may be inclined in the upward direction or it may be inclined in the downward direction. Hence, we have to consider the error caused because of the curvature, refraction, as well as the inclinity of line of sight. Now, let's simply concentrate about our line of collimation. So, this particular line of collimation, let's assume that it is making inclination of theta with respect to the horizontal and it is inclined in the upward direction as such. So, truly speaking, we wish to take the reading AA and BB, but we are actually reading AA1 and BB1. So, here AA is true reading, AA1 is actually observed reading at A, hence the error caused is a difference in that two readings, which is nothing but this AA1, which is nothing but d tan theta, d being the distance in between the instrument position and the stop station. On the other side also, the OB distance is nothing but d. Obviously, inclinity over the same distance as we have used the same equipment will be same, and hence the way we work it out here, the true reading at station B will be BB1 minus d tan theta. So, here true reading AA is AA1 minus d tan theta, true reading BB is BB1 minus d tan theta, hence the difference in that two readings should be true difference in elevation, which comes to be AA1 minus BB1. Thus, as you see, the error due to the inclination as well as the way we considered about that curvature as well as refraction is totally eliminated. And hence, the difference that we get apparently as AA1 minus BB1 is equal to AA minus BB, which is nothing but true difference in elevation. So, as we balance the length of backside and foresight, we'll be able to nullify the error likely to be involved because of the various reasons. Now, one more concept is of reciprocal leveling. See, there could be some particular site situation. Say for example, the way I have shown here, there is certain water body, there is a lake, river, or there could be certain valley as such. Hence, we cannot set the equipment exactly midway of the two stations that are under consideration. So, here we cannot balance the length of backside and foresight. Here, what we have to do is adopt the reciprocal leveling. So, in reciprocal leveling, we set the equipment at, say, station A, and we take the reading reciprocally on both the stations which are placed across the back. Then we move to station B and we follow the same process. By making use of this particular set of readings that are obtained as A1 B1 and A2 B2, we can determine the true difference in elevation as well as the magnitude of error involved in between A and B. So, in continuation, see here, there is station A, station B. Say equipment is placed very close to station A, hence the stop reading taken is A1 and stop reading taken is B1. The way we discussed previously, the line of sight could be inclined downward or it could be inclined upward. Here, let's assume that it is inclined upward. As such, here the amount of error involved with respect to level line is E. So, here we wish to determine the true difference in elevation, small h, as well as we wish to quantify the error involved because of curvature, refraction and correction. So, in the first case, the way we discussed previously, correct stop reading at A, because here the stop is placed very close, there won't be any effect of curvature, refraction as well as collimation, and hence the reading taken A1 could be considered as correct reading. Whereas in order to determine the correct stop reading at B, we have to deduct that error involved here so that we'll be able to get the reading corresponding to the level line. So accordingly here, the true difference between A and B can be expressed as H is equal to A1 minus into bracket B1 minus E. It indicates the fall from B to A. As we shift the equipment at station B, here again we'll be able to have the correct stop reading determined as A2 minus E. Hence, the true difference in elevation has to be H A2 minus E minus B2. So, as we make use of these two expressions, as we sum this H can be determined as A1 minus B1 plus A2 minus B2 divided by 2. So, here it tells us that the true difference in elevation can be determined by working out mean of two apparent differences that are observed between A and B. Please note, here we have assumed some things. Say for example, as we have considered A1 minus B1 here in order to determine that particular true difference in elevation, that means station A should have been placed at higher level as compared to station B. Similarly, we are deducting this particular E from this particular B1 in order to determine the true difference. That is, we are making certain assumptions of defining the relative locations of A and B as well as this particular inclinity of line of sight. So, as you take the observations, accordingly, the signs that you adopt need proper consideration. So, one thing I want you to ensure that don't follow any of such expressions blindly, but you follow stepwise process to determine the true difference in elevation. Here you can also see that we can work out that particular error E by working out the difference apparently observed and having it divided by 2. So, with the same concept, let's attempt one problem. Here, the station A and B is placed on opposite banks of the river, and here certain readings are taken reciprocally. We want to determine the true difference in elevation between A and B. So, situation is very clear. We cannot set the equipment in between A and B. Hence, we have adopted the reciprocal leveling. We have kept the equipment at station A. We have taken the reading on A and B. Again, we have shifted the equipment very near to B. We have taken the readings. So, here incorrect difference of the level when equipment is at A has to be 3.56 minus 2.156, which gives us 1.412. Similarly, incorrect difference of level when equipment is at B, it is 1.294. Hence, the true difference in level, which is nothing but the mean of two incorrect differences. So, accordingly, here what we get is 1.353, which is showing fall from A to B. Similarly, the way we discussed on the previous slide, you can work out that error E as 0.059 meter. So, here one thing you can see through this particular sketch schematically. Here on station A, reading observed is 2.156. As we have determined the true difference in elevation as 1.353, that means this vertical ordinate should be 1.353. As such, the actual reading corresponding to that same level line or horizontal line should be sum of 1.353 and 2.156, which is nothing but 3.509. But as you see here, the reading is worked out as 3.568, which indicates the line of sight is inclined upward. Just to understand the concept and how to deal with the numericals, I have discussed this particular example, but as I suggested earlier, please follow the steps that are shown on the previous slide. So thank you for your attention. I hope concept of profile leveling, cross-sectioning and reciprocal leveling is clear to you. So you have got enough background related with the leveling works. Hence, in coming presentation, let's discuss about the precision involved in leveling works. So, bye till then. I wish you very happy learning. Thank you.